Hello guys, I'm just going to continue lecturing on section 3.5. So let's rehash a little bit. We were talking about rational functions, okay? And you need to consider domain, and then you need to, when you start graphing it, you need to look at your vertical asymptote line and a hole in the graph, okay? And you need to understand when you're going to get a vertical asymptote line and when you're going to get a hole. It cannot be both on the same x value, right? Okay. So in order to get a hole, we talk about that in class. That means they have to have what? A common factor between the top and the bottom. And that's what the hole is going to be. So that means after you reduce the fraction, then you're going to replace that x value back into your reduced fraction, and that will determine your hole. And that will be, when you grab it, that will be where the hollow circle is going to be, all right? Okay. And then how about your vertical asymptote line? Well, your vertical asymptote line, after you reduce the fraction, then when you replace whatever number back in there, that will give you undefined value. And that will determine your vertical asymptote line. All right? Okay. So let me just look at a problem. So therefore, you could see, like this one that we just covered. You notice the x will divide out. So that means you have a hole at x equals 0. Okay? And once you and how do you find your hole? Then you replace x with 0. Okay? And your hole will be, replace x with 0 here, your hole will be at what? 0, comma, negative 2/3. That is where your hole is going to be, right? So, and that's exactly what we have right here, 0, comma, negative 2/3. Okay? Now, you look at the reduced form, since x cannot equal 3, so therefore when I replace 3 back in here, you will have an undefined value. So when you have undefined value, that means you have a vertical asymptote line. So basically, that's what you need to know on your vertical asymptote, difference between vertical asymptote line and a hole. Okay? You cannot have a hole and a vertical asymptote line at the same identical x value. It's either one. So make sure you remember that. All right? Okay? All right, so let's go back and then look at your horizontal asymptote line. Okay, there are only two ways you could get a horizontal asymptote line. We're looking at the degree. If the degree on top bottom is bigger than the degree on top, right, then you will have a vertical asymptote line. Right? So that means this n is bigger than m. So that means this is a dominant term. It increases more rapidly when you replace x for a huge number. Your horizontal asymptote line is nothing but the end behavior. Right? Okay? And that means you take a number, divide by a huge number, then you get 0. So that's why you have y equals 0. Right? Okay? And the second way you could have a horizontal asymptote line, that means when those two are the same degree, if they are the same degree, and it will become the coefficient of the ratio of their coefficient, it will be a sub n divided by b sub n, right? Okay. And the only thing you need to also know is when are we going to get a oblique asymptote line? Well, to get oblique asymptote line, the top have to be one more than degree in the bottom. So this one, m, have to be one more degree than n, right? Okay. That means m turn out to be equal to m plus 1 degree. So if this was third degree, that would be second degree. Then you will have an oblique asymptote line because the third is one more than 2. Okay. And that's what we need to know on those asymptote line, horizontal, vertical, and a hole. To sketch the graph, you need to understand what direction does it pointing. And we did that, didn't we? Here we go. Where are we here? we did this problem, we did that problem, didn't we? Okay. Okay, I skipped that one, it's going to let you try that one. Okay. Okay. And find all asymptote in a whole. In this case, you notice right here. So let's go through this one. What do I have? Horizontal asymptote line? Or do I have none? Or do I have oblique? Well, look at what case am I dealing with now. The degree right here is one more than the degree right here, so therefore you will have oblique. To find oblique, and what is the tell you do? You're going to divide it out a long way. Okay. All right. And x minus 4. And you do know how to, you could use synthetic division for that problem, but since some of you are having trouble with long division, I'm just using long division, and make sure you remember how to do that. Go into 2x times, and minus what? 8x. And then you're going to subtract. This become a positive 8 now, so when you add, you get, it would be 3x plus 3. Alright? And it go into positive 3 times, minus 12, and you subtract, this comes in 15. And basically this would be plus 15 over your divisor, and that will become 0 as x approaching infinity. When x get larger and larger, this portion you could ignore now because that portion is going to be 15 divided by a huge number will be 0. Okay? So that's why this is your oblique asymptote line. So y equal 2x plus 3 is oblique. Okay? All right? Okay? So we did finish this one, didn't we? Okay. So let's finish up on the rest of them. Okay, let's go to the next one. We're going to answer all the questions. Let's factor this. Is this factorable? Yes. Yes or no, guys? And you should follow what I'm doing here. That would be minus 4 plus 1. Yes? That will give me what? That's not... Oh, no, I'm sorry. There's 2, not 4. That will give me negative 4 plus 1 will give me negative 3. All right? So domain is what? This would be what? Negative 1/2, right? So that means x cannot equal negative 1/2, and x cannot equal 2. So what's your domain? Negative 1/2, negative infinity to negative 1/2, union with negative 1/2 to positive 2, and union with 2 to infinity. So again, you have 3 sections just like you did over here on the problem that we did in class, right? Okay, so let's go through vertical and a whole. Okay. So what I need to do is reduce my form first. So let's reduce. Since I roll over, I might should use this for reducing. So you have y equal the factor with x minus 2, x plus 1 on top, and on the bottom we already simplified that, factored that. Now you do know we have a common factors, okay? That divides out. And what's that tell you? One of the common factor. That means you have a whole at 2, right? Common factor imply whole at x equal 2, right? Okay, so to find the y value, you just have to replace x with 2. So y equal 2 plus 1, and this would be 2 times 2 plus 1, and that would be 3 over 5. So the whole would be 2 comma 3/5. Okay? Now, then we're going to look at the reduced form. Okay? So when x is negative 1/2, this will be undefined. Okay? So because x equals negative 1/2, okay, then that will be undefined. Right? Okay. So in this case, that will give you what? 1/2, this would be 1/2 over 0, which is undefined, when I replace it back in there. So what's that imply? Imply you have a vertical asymptote line of x equal negative 1/2. Right? So let's go to horizontal. So you have vertical, you have a hole, and what's about horizontal? Do we have a horizontal? What case are we looking at? The degree on top and the degree on the bottom are the same because the highest degree. So therefore that leaves me with the coefficient right here. So same degree. That means m equal n. So this implies y equal 1 over 2. Coefficient of the highest degree. So we covered the whole vertical asymptote line and a horizontal. And there's no oblique, because once you have horizontal, you cannot have oblique. Right? Okay. So let's look at the graph. By, right, you have vertical, x equal negative 1/2. So there you go. This is negative 1, and you're going to have negative 1/2. Oops. I'm moving to over there. All right? And it would be nice if and you have what? Slope here. This is positive. This is 1. This is y equal. This is y equal 1/2. This is x equal negative 1/2. How's that? All right. So it would be nice if I have some point. If I have some point, then I could use the point to guide me, whether it's by my graphs as when I get closer and closer to the asymptote lines are pointing up or pointing down. All right? So that's why we're asking you to find what the x-intercept and the y-intercept, right? Okay, so let's find the x-intercept. What is the x-intercept? To find the x-intercept, you're going to do what? We're going to have to look at the reduced form now, guys. Right? So you're going to let y equal 0, yes? So if I let y equal 0, so that will give me 0 equal x plus 1 over 2x plus 1. And you clear the fraction, that would be 0 equal x plus 1. So it crosses at x equal negative 1. Okay? So I have a point right there. Isn't that nice? What's the y-intercept? Because that predetermined my graph already. What's my y-intercept? To get the y-intercept, your x-intercept is negative 1. To get the y-intercept, you're going to let what? Let x equal 0. So y become 0 plus 1, 0 plus 1, so also equal 1. So there's your y-intercept. Right? Now I have a hole. And let's plot the hole. The hole is, let's be 1, 2, and positive 3/5. And positive 3/5 is going to be above 1/2. So this is positive 3/5. That is your hole. Okay? I hope you could see it here. Now, I could go through what happened to y as x get closer and closer to my asymptote line, right? So, but the point would determine that, so therefore in order for me to go from here to here, it got to go this direction. So it got to point up. And this one approaching toward your horizontal asymptote line. All right? That one got to go this way. Got to point down. And it got to point. All right? So you have a hole, and you have vertical asymptote line, your horizontal asymptote line. You notice I did not ask the question, what happened to the y value as x get closer and closer to your asymptote line, because those points will predetermine that. If they do ask, so well, obviously, as x get closer and closer to what? Negative 1/2, y will become positive infinitive. That means pointing up. As x get closer and closer to x equal negative 1/2, and your y value will be negative, will be pointing down, right? Negative infinity. So there will be positive infinity there, negative infinity bottom. Okay? So, but you have to go through all that. Right? And you notice in this problem, I only have 1 point, and that's why we asked the question, is it going to be positive infinity or negative infinity as we get closer and closer to the asymptote line? Right? So let's do the next one, guys. Okay. All right, the next one, right here. Okay. All right. So domain. What's the domain? Let's factor them here first. X plus 3 times x plus 3, right? Okay. So the domain is, well, x cannot equal to negative 3. So the domain turned out to be from negative infinity. Let's see if you can see it because it's kind of dark here. Comma negative 3, right? And union with negative 3 to positive infinity. So in this graph, there's only 2 sections, right? Greater than 3, negative 3, less than negative 3. While over here, we have 3 sections, except it's going to separate it by your hollow circle right here. This one is exactly 3 sections right here, right? Okay. All right. So vertical. Okay. And I need to see if I could reduce the fractions. Can I reduce the fraction? Because, well, if you take the x out right here, that would it would be 2x plus 3. So there's no common factor, is it? Right? So that means if x cannot equal 3, that will give me what? That will give me undefined value, right? So if I replace it, it would be x equal negative 3. And whole? None. And that's because there's no common factor between the top and the bottom. Okay? And you could write, so make a comment so you know, because no common factors between top and bottom, which is the numerator denominator, right? Horizontal. All right. And I look at the degree. The degree on top and the degree on the bottom are equal. So therefore, I should have y equal 2 over 1, which is equal to 2. Okay. Okay. Would be nice. This is from the theorem. I also teach you how to justify that. So let's do this one. I'm going to justify that for you. All right. So make sure you know that when I ask justify that this is your horizontal asymptote line without using your theorem, then you would say, let's look at the highest power, and they both do the second. So I'm going to take justify right here, since I'm over here. All right, I'm going to divide the top and the bottom by x squared. Okay, let's see. I'm going to divide this by x squared. I get 2. I'm going to divide that by x squared. I will get 3 over x. Right? We're dividing by x squared, the highest power. And divide on the bottom, this would be 1. And divided by x squared would be 6 over x. Divide by that by x squared would be x over 9 over x squared. Right? Since horizontal asymptote line is nothing but end behavior always saying as x get larger and larger, what happened to the y value? Well, as x get larger and larger, this becomes 0. Right? So that will be 2 plus 0. And this becomes 0. That becomes 0 when x get larger and larger, because you take 6 divided by a large number, 9 divided by a large number. So that will be 1 plus 0 plus 0. And that's why you have 2. Right? That's your justification on your horizontal asymptote line. All right. So let's look at your x and y-intercept. All right. So do I have an x-intercept? How do you find the x-intercept? You're going to let y equal 0, and that become x, 2x plus 3 over x plus 3 quantity squared. And since it's a fraction, I could always multiply both sides by the LCD. This implies 0 equal x times 2x plus 3. And this is a zero product property. Set each factor equals 0. So x equals 0. So crosses at 0. And 2x plus 3 equals 0. So x equals negative 3/2. Okay? So you have 0 and negative 3/2 for the x-intercept. Now let's look at the y-intercept. How do we find the y-intercept? We're just going to let x equal 0. So that would be 0 plus 0. This would be 0 plus 0 plus 9. Right? And that implies 0. Okay? All right? Okay. So far, let's sketch the graph. And by drawing your vertical, x equals negative 3, and I have a horizontal as y equal 2. You know that I drew that. I have a x-intercept is 0, and x-intercept is negative 1.5 right there. Okay. All right. Okay. Now we have how many sections? We have two sections now. Don't forget this portion. You have to give me the graph of that portion. This practically is already predefined. All right. Okay. And it's going to go like this. When I connect those 2 points together, you cannot go draw a straight line. You know it's going to come down here and eventually go back up here, right? Okay. Now, this is a good example showing you that it will cross this horizontal asymptote line. Okay? So where's it cross? That's a good question, so we will find out. Right? Since the horizontal asymptote line is 2, so you're going to say 2 equal, right? And what? Your function. You want to find what value of x it crosses over here, right? Okay, so I'm just going to clear the fractions. 2 times x squared plus 6x plus 9 equal 2x squared plus 3x. Multiply both sides by your LCD. There's only one denominator, that is your LCD. So you simplify. Plus 18 equal 2x squared plus 3x. How's that? And when you subtract, that be gone. And let's put all the variable x in one side. That will give you 9x and equal negative 18. Okay, put it, that's not right. And x equal negative 2. It crosses when x is negative 2. So when x is negative 2, what is the y value? Let's find out here. And the y value obvious is 2 because y is 2. So therefore it crosses right here. That's what it crosses. And with that in mind, you will go that direction. All right. Okay. Now, you have the second part. Some of you would just ignore the second part, then there will be points taken off because you have 2 pieces. I mean 2 sections, one on this side, one on that side. Look at your domain. All right? So let's do that. And what portion does it go? Does it go up here or down here? Well, it can't be go down here. Go down here, you would have an x-intercept, right? So you want to find out. So what you want to do is to say, hey, what happened when x get closer and closer to negative 3? Well, in this case, when x get closer and closer to negative 3, your y value will be positive infinity, and it's going to point up, right? And then since this horizontal echelon line, it will go right there, guys. Right? So that's your complete graph for that particular function. All right. Okay. So we also today we'll also look at what point will the graph crosses the horizontal asymptote line, right? You notice your graph never crosses the vertical, so it's got to be horizontal. So that's why, since this is 2, your y value be 2, you will find the x value, right? The x value turned out to be negative 2. So it crosses at the point negative 2, 2. Okay. And question will ask you that, so you're going to have to find the value on your homework. All right. Okay, so we're ready for the next one now. All right. Okay. Let's look at, see if automatically here. You should know that the top degree is 1 more than the bottom degree. So automatically you know there is a oblique asymptote line, right? I hope you realize that. So let's look at the domain. X cannot equal 4. So the domain would be from negative infinity to a positive 4, union with positive 4 to positive infinity. Again, going to be 2 sections. You want to give me the graph of greater than 4 and less than 4, right? Okay, do we have a vertical asymptote line? Yes or no? The answer is yes. Okay, because there's no common factor divides out, so therefore obviously there's no hole. So if I replace x with 4, it would be undefined value. So x equals 4 is the vertical asymptote line. Okay, and since I already told you there's no hole because there's no common factor, no holes. Horizontal, since you have horizontal, none. Right? That's because you're going to have oblique. So do we have oblique? Yes. And because what? The degree on top, which is the numerator, is 1 more than degree on the bottom. Alright? So you will have 1. So that means you're going to define it. So to find it, you're going to have to divide. And we already did that problem in case you didn't know. X minus 4. Right? Does everybody know how to remember? Maybe I should do syntactic division to remind you. Well, I already did long division for that one already. Okay? So let's do this syntactic division for this one so you can see. That would be 2, negative 5, 3, divided by 4. That would be 8. This would be 3. And this would be 12. That would be 15. Okay? So you have 2x here, plus 3. And that you could ignore because 15 over your divisor would be, as x get larger and larger. Okay? So you will get y equal to x, which is exactly. I use the same problem so you can see it. We did the same problem over here. Right, this one. Right. Okay. On oblique asymptote line. Right. So I'm ready to sketch the graph. All right. And maybe we should find the x and y-intercept also, and that will help me so I don't have to look at what happened to the graph as x get closer and closer to the vertical asymptote line, right? Okay, and x-intercept. All right, to find the x-intercept, what should we do? All right, we're going to let y equal 0, so that becomes 0 equal 2x squared minus 5x plus 3. You notice I already cleared the fraction to save me a step here, right? If this was 0, when you clear the fraction, 0 times x minus 4 would be 0. And this is factorable. 2x here and x here. And this would be 3, and that would be 1. Now both of them negative, and that will give me the negative 5. So you have 3/2 and 1 as your x-intercept. Okay? And how about the y-intercept? Y-intercept, we're going to let what? Let x equal 0. When x equals 0, that becomes 3 over negative 4, right? This becomes 0, that becomes 0. So the numerator is 3, the 0 here. Denominator will be negative 4, right? Okay, so we can sketch the graph. Let's sketch all the vertical asymptote line and horizontal, oblique, whatever I have. So your vertical is x equal what? Negative 3. Is that right? So 1, 2, 3. Right? Okay? So let's do that. Boom, 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 boom. And let's get your what? No hole, horizontal, no, oh, I'm sorry, x equal 4. 1, 2, 3, 4. This is 4, guys. I'm in the wrong set. I was looking on top. 1, 2, 3, 4. There you go. Okay. And no hole, no horizontal, oblique. Let's grab oblique. Your oblique is y equal 2x plus oblique. 1, 2, 3. That means I go up 2. 1. Okay, so there's your oblique. And I'm going to extend that one up here. This is none, okay? I make a mistake over there. All right. So let's sketch the graph and put the x-intercept and y-intercept in there. Your x-intercept is negative 1 and positive 1.5, right? Which is 3/2. Oh, no. Yeah, 3/2. And your y-intercept is negative what? Negative 3/4. Negative 3/4 right here. Oh, 3 here, positive 1, not negative 1. What did I get? Negative 1. Oh, positive 1. Oh, positive 1 and negative 3 here. No, that's not. Here's positive 1, guys. Positive 1's here, 1.5's here, and your y-intercept's here, all right? Okay. So for me to complete the graph, I know I have to connect those. Those got to go up, come back down, and then eventually, well, hit my down here someplace. We'll hit my vertical asymptote line, and obviously got to hit the negative 3/4. And as x get larger and larger, that means it will get closer and closer to the oblique asymptote line. That's where your graph will go. Now don't stop there. You have one over here. Okay, the one over here is got to be go this way. And now you don't know what that point is. You only need calculus to find that. And then you're going to come down here and hit that horizontal. Okay. And that's what you should have. All right? So what you want to do is finish this, listen to the tape, recording, and then practice your problem. All right? Okay, I will send you all the stuff that you need. And I'm going to go into the next section, guys, which is your variation problem. Right? Okay, your variation. Okay, this is section 3.6. I just got done with 3.5. Let's see, you remember. Okay, remember the graph. Y equal k over x. Okay, this is Do you remember? Well, this is nothing but stretch for this graph. What is this graph called? Reciprocal function. Remember that? That's your basic graph, right? So if I want k, that means I stretch that graph by the factor of k, all right? Okay. And as a matter of fact, there's a name for that graph. It's called, the name is called the rectangular hyperbola. Okay. You will study that. That's a conic section. That's called rectangular hyperbola. Okay. Right, so what we want to do is, you remember the graph is this way for your reciprocal function, okay? But when we're dealing with a variation problem, we always take k to be positive, okay? It's not a non-zero real number. We're going to say non-zero positive real number. Let's do that. So, right? So we have three kinds of variation: direct, inverse, okay, and the joint variation, okay? And the one the reciprocal function is referred to the inverse variation, right? Okay. Except we're going to only look at the k value to be positive, so therefore you only invalidate that portion of the graph, just one branch, right? But if I invalidate both negative and positive, you will get all those. That's a reciprocal function, right? Okay, let's find out. All right, when you see that statement right here, y varies directly as x, and you will write the equation as y equal kx. That means when x increases, y increases, they're related directly. Sometimes they will use the word proportion, right? Right? So if you, no matter what you pick, if you pick y and x belong to the graph, your divider, you're always going to come out with k. Right? So that means you increase one variable, you will have to increase your other variable. You decrease one variable, you decrease the other one. That's why they related directly. All right? So when you see that direct variation right here, inverse directly, you would write the equation y equal kx. Right? And you notice y equal kx is nothing but a straight line. And you don't look at a negative value, so the one you only invalidate k to be positive, so therefore go down. We don't need using the first quadrant here. Okay, all right. And what happened to your other y varies inversely? Inversely means that what? One increase, the other one decrease. One increase, the other one will decrease. That's why I call it inversely. Okay. And don't forget, your k value is called a constant variation. So you have to have a k in there when you're dealing with variation problem. All the variation problem have a constant variation. Right? Okay. So let's look at the translation. When you say y varies inversely as x, you will write the equation y equal k divided by x. That means you increase this one, you're going to have to decrease that value. Right? Okay? Because you divide by a larger number, your y will get smaller. If you decrease this one, you're going to have to increase that number. So that's why they verse inversely. Right? Okay. Your third variation is going to be y vary jointly as x and z, and that's a product of those variables, two variables. So that means they're related directly to y. Okay? So y vary jointly to x and also to y. So y basically varies directly to x and y varies directly to z. Okay. Okay. You see, is it very directly as a product of the two or more variables. All right. So the first thing you want to do when you're doing variation, you be able to translate into equation form. So let's practice a little bit. So you need to pick a letter that you could remember what they're representing. So I'm going to underline. All right. I'm going to let P represent pressure. Okay. And what else? Oh, I'm going to let, that's my other variable. Little d stand for the depth of the point beneath the surface of the liquid. That's irrelevant. I'm just looking at what are the variables? So my equation with P equal K, and since this is a direct variation, and KD. Okay? And let's look at that one. I'm going to use current for C, and my other variable would be resistant. Let's use R for resistant, all right? And my variation is inversely. So my translation would be C equal K divided by R. That's an inverse variation. And let's look at this one. This will be force. I'm going to use F. And joining to, there's two variables here. Joining means I have two variables. Mass is M. And I'm going to use acceleration as A. Okay? Okay? And joining means it's the varies directly to the product of those two. So I would say Y equal K MA. So get the knack of it. Let's see if you could do that a little bit on your own here without looking at what I'm doing. Okay. A stands for amount. Varies directly. I'm going to circle it. This time the square you got to understand now is not linear now. D diameter. That's D stands for the diameter of the pipe. So your translation would be A equal K. Now it's not directly linear to the diameter. It's the square of the diameter would be D squared. Okay. Have I got that? I hope you translated correctly, because you're going to have to do a word problem about translation, then find the value. All right, the period. I'm going to let P stand for the period, so you know. And the variation varies directly. And this would be the square root now of the length. I'm going to let L represent the length of the pen. And now you get another variation inversely, and the square root of acceleration. And A will stand for the acceleration. Right? So P equal, and you still have a K. Right? That would be the same K throughout the problem. Variation, directly as the square root of L. Oops. And inversely, meaning I'm going to divide, and the square root of acceleration. Okay? So you get the knack of it now? So now we'll do an intensity. The I represent intensity. Varies directly at the wattage of the lamp. So therefore, I'm going to let W, how's that? And inversely, and the square of the distance, I'm going to let D represent the distance. So you say I equal directly as what? Wattage to the lamp. Oh, so it would be W, that's a direct variation, and it's inversely to the square of the distance would be D squared. Okay, let's do this one. P stands for power, and jointly, very jointly now. That means I have two variables in here. So current, I'm going to let C, and resistant, I'm going to let that represent R. So it would be P equal, right, K times C and R squared. Directly to C and directly to the square of the resistance. Right. So the first thing you need to do is be able to translate. Right. Okay, once you translate, we're going to do an application. Right. To do that, the procedure in solving variation problem. Okay, write the equation for the general variation. Right. Then you got to find the K value for the problem. Okay, that's the best thing to do. Is they always give you enough information to find the K value. Once you find the K value, then you could find whatever other variable they require you to find. Right. So let's start. The first thing I want to do is write the variation. Right? So the variation is y equal, what should I write? It's jointly now, right? So it would be k, there would be two variables, jointly as what? Z, and the square root of w. There we go. Okay. So that is the first thing, right? The variation problem. We're going to find k. They always give you enough information to find k right here. All right. So they say when y is 42, all right, z going to be 3, and w going to be 49. Now you have no problem solving for k, so that would be 42 equal, this would be 21k, and divide both sides by 21, k is equal to 2. So what's it tell you? It tell you y equal 2. Once you find a k, it's going to be the same k throughout the problem. So you should replace the k for that, and z, w. So the k constant proportionality is going to be 2 throughout the problem, whatever they want you to do. Now, let's do A. Part A. You are finding y now when they give you z and w, so that's no problem. 2 times z is 4, and w is 9. Right? And that should turn out to be 8 times 3, that will be 24. So your y will become 24. So let's do B. And I still have the same identical constant throughout the problem. All right, now they want me to find w when y is 24. All right. And they got different z value now, so don't say, all right, so with 2 times z is 8 times square root w. Okay. All right, so you get what? 24 equals 16 times square root w. Divide by 16, and don't try to square it. They're big numbers, so I reduce it first. That would nothing but what? 3/2 equals square root w. Now to find w, you have to square both sides. That will give you 9/4. And that's what w is right here. Okay? So the procedure is write the variation, find the constant k, and then answer whatever they ask you to find. Okay? Okay, let's look at the second example. Volume. What kind of variable? Inversely proportion. This is very directly inversely to pressure. So I'm going to let P represent the pressure, V stand for the volume. So your variation will be Y equal K, V equal K over P. Make sense? Now what's it going to do? Well, they give you enough information to find what K. So the volume is 8, and the pressure would be 3 atmosphere. So that means K will be equal to 24. Okay. All right. So therefore, V equal 24 over P. Now you could either find V or P according to what they ask you to find. So they say let's find the pressure when V is 4.8 liter. 24 over P. Okay. So all you have to do is solve for P. So multiply both sides by P equal 24, and then you're going to divide both sides by 4.8. Okay. If this is a non-calculator problem, you would multiply top and bottom by 10, and then divide 240, divide by 48. If this is a calculator problem, you would punch it in, and you will get 5 as an answer, and the unit is going to be what? Atmosphere. Okay. So how are we doing? So you grasp the concept so far? All right, so make sure, I think this is an easy section if you practice. It doesn't take that much practice to understand this, right? But you can understand the 3 different variations you have, right? Okay. All right. So let's look at resistant. I'm going to use R for resistant, and I'm going to use L for the length, and I'm going to use D for the standard diameter. All right. Now this is the way they measure now, so you do not need to convert millimeter to meter, because if you set up a proportion, your unit will divide out anyway. So we will keep the unit the way it is because that's how they measure it. Right? Okay. Your diameter is always a millimeter, and your this 50 length right here is always a meter. Right? So let's write the variation down first. The variation will say what? R equal K directly related to the length, and inversely to what? The diameter square, right? Okay, let's find K. Okay, so your resistance at 10 ohms, and your length is 50, and this is 2 millimeters, and you get the square. So this is 4, so you have 40 equal 50K, and imply K equal divide by 50, then you get 4/5. How's that? So we're good? Alright, so therefore, I'm going to do my substitution for K. So if this were equal 4/5 L divided by D squared, and let's make sure I don't like to have fraction there, let's make sure I rewrite it again, would be 4L over 5D squared. That looks much better, right? Because that probably confuse you when you do it like that. Okay. Now, they could tell you find R, they could tell you find L, they could tell you find D. Okay. So they have to give you, there's 3 variables in here, they got to give you 2 to find the third variable. So let's see what they want me to find. Find resistance, that means R. So do I have to do just basically substitute? The length is 120, and the Y have what? 3 millimeters, so it'll be 3 squared, right? Okay. So that would be 4 times 120 over 9. Okay, if there's a there's a phi in here too. Yeah? If there's a non-calculator, you just have to reduce. I mean, just phi going to phi 1, this going there, and you get a 9 here. So that's why I didn't multiply them out. If this is a calculator problem, you just type it in and punch it in. Okay? So make sure now to reduce the fraction without going through a lot of hassle of multiplying. So why don't I just say, hey, this is a non-calculator problem. You're going to have to reduce first. So phi going to phi 1s. Okay? And phi going to 120. How many times? How many times? 20, what, 4 times? Right? Phi going to 12, 2 times. So 20. Phi going to 24 times. Now there's a factor between 9 and common factor. 3 going to 9 3 times. They're going to 8 times. So it will be what, 32 over 3. And that's how many ohms you have. You want to convert in a decimal, would be 10.6 with a bar on top, or 10 2/3. Okay. All right. So we have one more problem to do, and then wrap up that section. Okay. So let's see if you could write the variation for me. It's going to be jointly, right? Yep. So you have P equal. Now don't look at it. Try see if you can try to do that right, and then come back and look at it. See if cover up what I'm doing, or turn off the thing. Just watch my paper. I mean, cover up the paper, and see if you could do this one right. This is like we practice in class like that. And remember, I always say, "Now let's practice. Now you should be able to do this." It's hard right now because I'm talking. I have to get this done, so I have to write things down. Okay. So pressure equal K jointly what? Area. I use your A for area. And the square of the velocity, so V squared. There you go. That's jointly related to area and the square of the velocity. Area at the wall, right? Okay. Now we define K. So that means P is given, A is given, and V is given. So A is what? P is 120 pounds, and A is 100 square feet, and this is 20 miles per hour, right? So what is K? So you notice I did multiply now, and okay, divide by this. 100 times, this would be 400, right? Equal K. Okay. So I'm going to knock out a 0 because I divide by 10. So that will go out, right? Okay. And then I have what? 40 and 12 have a common factor. So 4 go into 12 3 times, and that will go into 10 times. So my K would be 3 over 1,000, right? 100 times 10 is 1,000. So my variation will become K 3 over 1,000 times A V squared. How's that? Okay. So which is equal? Now then you're looking for what? Find V now. So that means P had to be given and A had to be given. So what is P? P is 540. And A is going to be 200. And times V squared. Okay, I would reduce first. Knock out the 2 0. That means I divide both sides. 100 could go into there. Okay. So I'm going to multiply by 10, divide by what? Oh, maybe something else. Oh, yeah, 2 could go into that. 2 going to 2 once, and 2 going to 10 5 times. So basically I have 540 equal 3 over 5. Yes? V squared. How's that? Now I'm going to multiply by the reciprocal. Okay, so that means 5 times 540 divided by 3 equal V squared. Okay. Again, I could reduce. 3 going to 3 ones. That go in there how many times? Go in there ones. That gives me 24, 8, 0. And when I multiply for the 900 equal V squared. See, I didn't use the calculator. I could. I mean, this is a calculator problem. You could just punch it in. And I take the square root of both sides. And what is the square root of 900? You would, did I hear 30? Thank you. 30. Okay, so the velocity is 30 miles per hour. And that is what your answer is. Okay, so we wrap up this section. Right. So I shall go into the next chapter pretty soon. So look, I'm going to send you the information. So the next chapter is involved with the what? Finding the inverse, one-to-one, and then logarithms and exponential function. That is your fun chapter, I think. All right? So I'm going to lecture as many sections as possible and let you do the homework. Okay? And then I'm going to send you a note, say what you're going to do with your homework. You need to keep it in a book, and when you come back, I'll probably collect them and give you a grade for those. Okay? And I'm working with, see if I could have a quiz or test, because the math department is thinking of proctoring, some sort of proctoring in the computer process. I don't know how they're going to do that, but they're looking into it, because everybody wants, there have to be quiz, there have to be tests, and so forth. Okay? If that doesn't work out, I probably have to give a send you a take home, and you're going to have to learn how to send it back to me. Okay? That's the problem with the computer. Okay? People know what to do, and I usually probably don't know what to do. And I'm trying to sit here and try to grasp it all in and let them tell me what to do, and then kind of go in one ear, comes out the other. So, okay, I'll lecture probably either tomorrow or Wednesday for you. So, good luck and be flexible, guys. I know you have a lot of time, so don't forget you are still in school, so you don't want to fall behind, because by the time you come back, it's going to be you're going to have 2 more tests for me, and then plus the final. So you don't want to lose what you learn in here. You got to constantly keep up with your work, and so you don't get behind. Okay. Talk to you later.